I'm Jesse Burst of SmartGridNews. I'm your host and your moderator today. Welcome to our interactive webinar on end-to-end asset health. Very pleased to bring you this topic because I really think it's an opportunity that's being overlooked. Because, done right, you can spend less to achieve more. That's a great double win. Done right, you can lower your O&M costs while increasing reliability because you're finding problems before they cause catastrophic failures, because you're inspecting things that actually show evidence of problems, not just because it says to check it on a schedule, and other benefits we'll hear about in just a moment. So I'm very pleased to bring you this session also because I think ABB has a very robust solution, and it's kind of a winning approach, this end-to-end idea. I think you'll appreciate it as well, and we've got a couple of folks from ABB to talk about that way of approaching the issue. Also very pleased to have AEP with us because they're a little bit further along this asset health journey than most, and that means they've got more lessons to share. So I think you're going to find this a very valuable time. So here's what you'll walk away with today. First, you're going to hear about the challenge, but embedded in that challenge is this opportunity. Then we're going to talk about this end-to-end approach, end-to-end process. Then we're going to talk about this Asset Health Center and see some real specific examples. So this is a real kind of roll up your shirt sleeves, real world look at this topic. And then finally, we'll end up with some of AEP's lessons learned. They'll march us through what they've found. So it's going to be a great session. And here are the gentlemen who are going to bring it to you. I'm Jesse Burst. I'm with SmartGridNews. That's the Internet's oldest and largest smart grid site. I'll introduce everyone in more detail when it's their turn to talk, but very briefly, we were joined by Chris LeMay. He's the product manager at Ventix, the division of ABB. Gary Ratcliffe, who's the vice president of Smart Grids for North America for ABB, and by Carrie Schneider, who's with American Electric Power. And with that, I'd like to bring up Chris LeMay. Chris has got more than a decade in delivering solutions to asset-intensive businesses, so he certainly knows what he's talking about. He also gives back to the industry. He's part of the IEC working group on the Common Information Model, so we're very glad to have him. Chris, thanks for joining.
Thank you very much, Jesse, and thank you for hosting this webinar. So the kind of subtext here is that, as Jesse was saying, done right, we can manage the health of our assets, taking advantage of kind of new technology and new data that wasn't available before, and basically work smarter, not harder. And so, this is important. As Jesse said, we have a number of challenges in front of us in the utility industry. We have aging infrastructure, that is the infrastructure getting older, more difficult to maintain. At the same time, the experts who are skilled in knowing and diagnosing what's wrong with the equipment is starting to walk out the door in ever greater numbers. And at the same time, the expectations for reliability aren't getting any lower, and the standards around reliability and the need to document and be clear about what we're doing is not getting any less either. And then on top of all that, it's not like there's more money available to address these challenges. In fact, the asset base for most utilities is slowly increasing, while the O&M budgets are being held flat or even decreasing in some cases. So really, all of these challenges, and then the other one which I added here is more of an IT challenge. It's around, there's a lot of devices out there that are starting to produce more and more data on the grid, and storing and using that data is in some sense a challenge. But we like to believe that behind every challenge lies also an opportunity to do things different. So one of the ways we think we can change some of these challenges into an opportunity is to, it looks like we have a fire alarm here. I'm really sorry. Gary, if you can take over, I'll dial back in as soon as I can.
Sure. So let me just pick up where Chris left off. The particular slide that you're looking at describes the OT-IT convergence that we're seeing around utility analytics. So some of the challenges are, how do you manage the larger volumes of data that are now available from the grid, both from historians such as SCADA EMS as well as real-time sensor technology, but also being able to sweep information from test reports, inspection reports, maintenance reports, and other sources of information, and being able to provide the analytics that drive value from that data. And the analytics really does two things. It creates the opportunity to predict or forecast based on historical and current information, and it also provides the ability to optimize processes. And so that's what we're trying to capture with the OT-IT convergence as it applies to asset health management and the application of analytics to that process. Ultimately, what we're driving towards is reducing the risk of outages, particularly those unplanned outages or catastrophic outages that cause utilities nightmares. So this shows the overall end-to-end process for asset health management. And this is a modular approach to looking at the process going from the assets themselves, the monitors, the equipment, the sensors, and the monitoring systems to capture that information, substation communication gateways to extract the information from the substation, and then the management of that data, including archiving it and making it available for business intelligence models and the analytics that are shown in the dashed part of this diagram. And that's the part that this provides the decision support, looking at the operational impact of asset health, optimizing the maintenance, managing the asset life cycle, and having a transparent process for making business decisions regarding investments into assets, and then recommended work execution based on condition-based maintenance. And then finally, pushing that information to the various stakeholders, and then also triggering the work orders in work and asset management for execution. There is also a feedback loop, which isn't shown on this, but as you do work in the field, and as you execute recommended condition-based work orders, that process and that information needs to be fed back into the business intelligence model and the performance algorithms. So this breaks down the process that was shown in the previous diagram. In terms of data acquisition, we're looking at real-time data coming from the SCADA EMS system. Now, real-time needs to be interpreted. Generally, this is not real-time as in the control room, but we pull the data that is captured by the SCADA EMS system into the asset register or the asset database, and this information is coming from the SCADA EMS historian. We're also able to get sensor data, which is coming in. That can come in real time, and we can sweep that information into the continuous processing of available data in the Asset Health Center. That would include any alarms which might come in that don't go through the SCADA system, but also different parameters, which we'll show a little bit later in the presentation. We also can pull in data from the Enterprise Asset Management System, the Geographic Information System, Mobile Workforce Management. Those are all feeds and resources of information. And then we also have the enterprise data, which is available, certainly nameplate data, history on the assets, which we can also factor into the assessment. When you look at the data aggregation analytics, we're assessing basically risk of failure, and we're looking at the contributing factors to risks. So on a transformer, as an example, there's mechanical risk, there's the thermal risk, there's a dielectric risk related to the insulation of the windings and also the internal leads as well as the bushings. There's an accessory risk, radiators, coolers, pumps, and other accessories on the unit. And then there's miscellaneous risk, which captures things like environmental contamination and other factors that can create operational risk for the unit. And these apply to other types of assets as well, although the elements of the risk are perhaps somewhat different. For example, in high voltage breakers, you have similar risk profiles, although the dynamics of each of those risk factors will be different depending upon the type of asset and asset class. The decision support is to interpret the data and to make it actionable information. So part of that is capturing the KPIs and the metrics that determine and display the health of the asset. So we have a series of dashboards which are available to display and provide information to the numerous stakeholders that are involved in the asset health management process or the asset management process. Packaged analytics give a starting point. These are embedded algorithms that sit on top of the business intelligence model that can be used to analyze the data. However, these are user customizable. The notifications and reports, this is largely if there's a concern on a particular asset, or if a unit needs to be derated for operational purposes, we need to make sure all the relevant stakeholders are getting that information. And there's always ad hoc capabilities in terms of drilling down, doing queries on asset classes, asset locations such as a substation, or drilling down and looking at a particular unit out on the field. And then communications is key. One of the challenges I think today with asset health management is there's a lot of information, but it's stranded. Engineers collect a lot of data on the assets they're responsible for, but that information doesn't always get to the right people, and there isn't necessarily visibility of that information across the organization. So capturing that information, providing the analytics, driving the process through to execution of condition-based maintenance, smarter or more efficient investments to support lifecycle management of assets and reinvestment in the grid are critical outcomes.
Gary, could I just jump in with a quick question from James? He asked, is there a reason that meter data management systems were not shown as a data source?
Yes. The main reason they're not shown as a particular data source in this presentation is we're focusing more on what AEP is implementing, which is at the transmission level. So more focus on the transformer assets, their 765 kV and high voltage transformers, as well as their high voltage breakers. Where I believe meter data is particularly relevant is on distribution assets. And one example would be distribution transformer load management, where you can use either a meter on the transformer to measure load on that particular unit, or doing aggregation of the meters that are connected to the distribution transformer to capture what is the load so that the utility can better manage sizing of transformers, monitor if there's any distribution transformers which are overloaded, potentially overheating, and I would view that as an extension of asset health management, and that could directly use meter data. That was a long answer to a short question.
Very helpful, thanks.
So this particular chart shows the process schematically. So it shows in the lower left the multiple sources of information where we can pull data. There's different types of sensors. There's different databases, both online as well as offline. And then in the upper left-hand corner, we're showing some of the assets, the transformer, breaker, and that also shows medium voltage switchgear equipment. And so what we do is we pull that information and then we integrate it with subject matter expertise. And this is resources and expertise that utility has in terms of their stewardship of assets over the decades, as well as what we have from a manufacturer's point of view in terms of having the designs, building the units, knowing how they age and how they perform in service, and then also rebuilding, refurbishing, maintaining, and servicing assets from the field. When we combine the utility expertise with our expertise into the performance models and the analytics, we really drive the process forward. So we have an advanced business intelligence platform which enables us to manage the data and then provide the platform for the advanced algorithms to interpret the data and to determine condition of the assets. One of the drivers that we have is driving condition-based maintenance, and it's important to know, obviously, the condition and health of the asset in order to support that process. And then triggering actionable work for the work and asset management systems. My experience with work and asset management systems, they're great at executing work once you tell it what to do, but they're not so great at figuring out what's the needed condition-based maintenance. And so the asset health center concept really drives that process. So Jesse, I don't know if you want to introduce me or not. I've already started, but if you want to make a couple of comments, this is your slide.
Thank you, and I do want to recap. We started with Chris LeMay of Ventix, and Gary jumped in because there was a fire alarm at Chris's location. And we were talking initially about the challenges that argue for an asset health solution and some of the opportunities that such a solution can bring. That's what we've been covering. And, chief among them is this idea of turning raw equipment data into actionable intelligence that improves reliability while also reducing O&M costs. And this is where Gary was going to jump in, and I did want to introduce him because I've known Gary for years now, and I've always noticed that he's equally adept talking about technical issues and about business issues. And then when I saw his bio for this webinar, I realized why, because he's got a couple of power engineering degrees and an MBA, so he's not just faking it. He actually knows what he's talking about. Gary is one of the thought leaders of our industry, and we're real happy to have him here.